All right, guys, I wanted to post a quick tutorial about doing life tables because I'm going to be posting a demography lab for you guys to work on online. Probably I'll be posting that later today. I'll update you on the due date and all of that stuff. Uh, but let's jump into it here. So what we have here is you could think of this as a life table. What it actually represents is the number of players on, I guess this would be some kind of sports team who are um, returning to the program to keep playing in that sport throughout these different grades. And we start tracking it here in 7th grade and we go all the way through 12th grade. So let's just be super clear about what these things would represent if this were an actual life table and not just kind of an example of something that you could do with something like a life table. So this would be like X, right? Um, this would be our like generation time here, right? So the grades would be the generations or the periods is one way to think of that. Our next number here, the players who return, those are going to be our N of X individuals. So if this were a survivorship table, it would be individuals who are actually surviving. In this case, it's just players who return, but we're going to call it N of X. The next number we have is the percentage of players returning, or how many kids are you retaining each year. That is our L of X. All right, players who quit would be D of X. You could think of it as like a mortality rate or the number who quit. And the percentage of players who quit or age-specific mortality is going to be our Q of X. So let's see how we can calculate some of these things using Excel. If you remember from my previous lecture, L of X is going to be just the number of players who return divided by the number who you started with. So in this case, this is going to be equals D3. Hopefully you remember from our labs that we've done that you start writing an Excel equation using the equal sign, and then we specify D3 because that's the data we want to look at. So how do we calculate the number of players who return for this 0th or this first generation? Well, it's D3 divided by D3. Pretty simple, 100%. No other number really makes sense there. But let's calculate this next one and see what it looks like. So this is going to be equal to D4 divided by D3. It's the number of players who we have in this generation returning divided by the number that we started with, which gives us an 88% survival or thereabouts. Let me reduce this a bit. Let's continue calculating this. So how do we calculate our survivorship for the 9th grade? Well, that's equal to D5 divided by D3. That's pretty low. Let's do this. There we are. Let's keep calculating these. So we're going to say equals D6 divided by D3. I'm going to say equals D7 divided by D3. And then equals D8 divided by D3. And actually, if we wanted to, we could add like another grade here, but it doesn't make any sense, right? Because there is no 13th grade. So no one is surviving, nobody's coming back to play for another year after their senior year. So let's look at our mortality rate, or the number of players who quit from grade to grade. So how do we calculate that? Well, we're going to say this number minus the next number down. So it's going to be 154 minus 135 for this first generation. 154 minus 135, or we'll be smart actually, we'll say D3 minus D4. 19 players quit between 7th and 8th grade. We'll do the same thing down here. We're going to say equals D4 minus D5. 79 players quit this time. Let's keep on calculating. We're going to say equals D5 minus D6. I did that wrong. Excuse me, D5 minus D6. That's better. Equals D6 minus D7 equals D7 minus D8 equals D8 minus D9, and this one's just going to be 0. Well, you could say equals D9 minus D10 if you wanted to. Cool. So now that gives us sort of like a mortality rate. Now let's calculate our age-specific mortality rate. This is not a mortality rate. This is just total number of players who quit. Let's calculate that as a percentage basis. So we're going to say equals F3, equals F3 divided by, my keyboard would work, divided by D3. I'm sorry, D3. It's the number of players who quit divided by the original number. Suppose I should say it's the number who quit divided by the number you started with in that generation. So for this one here, for 8th grade, we're going to say equals F4 divided by D4. We can keep on calculating like this. You could say equals F5 divided by D5 if you want. Or alternatively, you can just click on the cell you just typed in, go to the bottom right-hand corner and drag that down. And this is going to give us a divide by 0 because it doesn't make any sense because there's no one left alive in that generation. So there you have it. Those are sort of the basic statistics that I'm going to ask you to calculate. The next thing I'm going to ask you to do is to actually generate a survivorship curve and an age-specific mortality curve. So I'm just going to go ahead and I'm pressing and holding the shift key. I'm going to click on this here. I'm going to press and hold the shift key and drag it down. Or actually, I'm going to press and hold the shift key and press the down arrow until I have all that data selected. Now what I want to do is plot a survivorship curve. So I'm going to press and hold the control key. I'm going to click here, and while still, oh, I lost it. I'm going to press and hold the control key, and while still holding the shift key, no, it won't work. Here's what I'm going to do. I'm going to grab these data, just click and drag, and then I'm going to press and hold the control key and click and drag and grab all of these data. Okay, this is our percentage of players who are returning. This is going to be our survivorship curve. So I'm going to go to data. I'm going to go to insert, chart. And we don't want a column chart. I would rather have a line chart. That's pretty good. So there you have it. This is our sort of faux survivorship curve. If you were to plot, like high school sports, just like you were going to plot survivorship amongst individuals in an ecological setting. Let's do another one. This tells us perhaps some interesting information. There's a pretty sharp drop-off here between 8th grade and 9th grade, which is kind of interesting because, again, these things can tell you about an organism's life strategy. So what does this tell you about the life strategy of people trying to play sports in junior high versus high school? Probably something. All right, let's go to the next thing we're going to plot, which is we're going to plot a mortality curve or an age-specific mortality rate curve. So again, I'm just grabbing all of these data here, grabbing all of these, clicking and dragging down. So I'm clicking on grade and maintaining that click all the way through 13. The next thing you're going to do is press and hold the control key and click on players who quit, drag all the way down here. When you do it, it's actually going to be called QX. It's not going to be called players who quit. That's okay. Let's go insert. We're going to insert another chart. Again, we don't want a column chart. Let's do a line chart. And this tells you this gives you an age-specific mortality rate curve. And you can see that it's not a lot between 7th and 8th, but it sort of increases quite a bit. And by the time when you get to 12th grade, it goes to 100% because, you know, again, you can't return for 13th grade and continue playing sports. But we have this sort of plateau here, which just means a lot of people are quitting in the 8th grade and a lot of people are quitting in the 9th grade. Now, again, if we were thinking about this in terms of high schoolers, what would this mean? Answer that question to yourself. What does this mean to you? Why would people quit playing sports in 8th grade and 9th grade? Well, you're going from junior high to high school, so the competition is perhaps a lot tougher between 8th grade and 9th grade. Why would we have a very high mortality, or why would we have a lot of people quitting in 9th grade? Well, you're going from junior varsity to varsity sometimes, or maybe you played for a little while and you weren't that good and you needed to find that out, and so you quit after the 9th grade. But it's very high in the 8th grade and the 9th grade. And then things sort of level out. 10th and 11th, it's fairly low, and then after 12th, obviously, it's 100%. Okay, so those are just some examples. Hopefully, this is making some intuitive sense to you about how these things can be used to sort of suss out or figure out life strategies. Because again, you know, 7th and 8th, you have 88% of players surviving. I'm doing dumb air quotes right now, but you have 88% of players surviving. And then between 8th grade and 9th grade, you only have 36% of players surviving. There are only 36% of the people who were playing in 8th grade are still playing in the 9th grade. Okay, this tells you about perhaps the difficulty of playing in the 9th grade. It tells you maybe people are more stressed out because now they're in high school, but it definitely gives you a lot of really interesting information. Okay, cool. Now let's look at an actual demography table, and let me go ahead. I've already done some of this work. I'm going to get rid of it. Okay. So L of X, again, this is our survivorship. I'm not going to go through the whole process long form. I'm going to show you, if you are so inclined, how you can do this more quickly. So this is our survivorship number. So this is going to be equal to D5 divided by D5. Make that capital. So if you want to do this more quickly, it won't work if you just type that in and then drag this down, because it's just going to keep on dividing that first number by itself. Excel is trying to be smart. It's trying to drag the formula with it, but it doesn't work in this case. So if you'd like, if you don't follow what I'm about to do, you can just say equals D6 divided by D5 equals D7 divided by D5 equals D8 divided by D5. You can do that. If you don't feel like doing that, if you feel like being lazy, which is fine, I'm pretty lazy, you're going to say equals D6 divided by $sign, if I can find it, $sign D, actually we'll just say D $sign 5. And I'll do that again. We're going to say equals D7 in this case, divided by D $sign 5. And you'll see what that does in just a second here. This, I have my $sign 5. It's written in there. What happens now if you go to the bottom corner here and you drag this down, you drag this formula with you, a little bit easier to look at, is it keeps dividing by that same number. So if you put a $sign by something in Excel, it will not change the value of it. So I'll show you what I mean by that. So, oops. Go ahead and get rid of these. So if I go up here and I go equals D 7 divided by D 5. I'll just drag it down 1. It's going to move the data you're trying to work with down by 1 each and every time. But putting the $ there prevents Excel from dragging that formula with you. Oh, hit the wrong button. Divided by D $5. Cool. Let's go ahead and drag this down. I think those numbers look reasonable. Yeah, okay. Now we're going to calculate D of X, or the number of individuals that are dying in each generation. So we're going to say equals D5 minus D6. 1182. So that's a lot of individuals that died. We could do the same thing here. We're going to say equals D6 minus D7. 2 individuals died here, equals D7 minus D8. And you don't have to keep doing this. This one's kind of simpler. You can just drag this down and it will get basically the right formula for you. Okay. It is, yep, D8 minus D9. Let's just check a random one. Yep, D16 minus D17, perfect. Okay, so this is our mortality right here. The next thing we're going to want to do is calculate our age. So what does that mean? What does age-specific mortality rate mean? And what is like the formula for it? So this is like the percentage of organisms that died per generation. So in this first one, we're going to say equals F5, the number that died, divided by D5, the number that we started with. Okay? So if we were going to do it for this one, we would say equals F6 divided by what now? Well, it's going to be D6, because that's the number that we started with in this generation. Let's keep going. We're going to say equals F7 divided by D7. Say equals F8 divided by D8. So this one is kind of, I think, illustrative and hopefully meaningful to you, because notice no individuals died between generation 4 and generation 5, which means our age-specific mortality is 0. Nobody died here. 0% of the population died. Everyone made it from generation 4 to generation 5. Let's do a couple more. We're going to say equals F9. Excel already, your sheets already knows what I'm doing. Divided by D9. Say equals F. It's suggesting it to me, which is kind of cool. F10 divided by D10. Again, we have another 0 because everyone survived here. I'm bored of this. I'm just going to go ahead. I know this formula is correct. Let's look at it and make sure that formula is correct. So I'm going to go ahead and click on it, click on that cell, go to the bottom right corner, and drag it down. We can just go ahead and get rid of this last one because it doesn't make any sense. And I'm going to make fewer significant digits. Rid of some sig figs here. There we are. All right, let's plot our survivorship curve versus generations. So I went ahead, grabbed our generations. Now I'm going to go ahead and press Control, grab our survivorship rates. Now we're going to go Insert, Chart, and there you have it. So what this shows us, what this shows me, is that there is a huge drop-off in survivorship between the 0th generation and the 1st generation. So think of some examples of this. What kind of organisms have low survival between the 0th and 1st generation? This might be like salmon swimming upstream. A whole bunch of salmon get eaten, they don't make it downstream. Or this could be like sea turtles. Many sea turtles never make it um, off of the beach. All right, let's plot our age-specific mortality curve. Grab all this data, and then we're going to press Control, grab our Q of X. We're going to go Insert, Chart. Okay. Oh, I see. So you see mortality is very high in the beginning, very high early on, and then it's quite level for a long time. And then once organisms start to reach, I don't know, we'll say the 15th generation, mortality starts to increase again until obviously it gets to that 100% mark. But this is your age-specific mortality rate versus your generations. Okay, and again, in the lab, I'm going to have you guys do online. I'm going to make you do a couple of these and make some inferences about what kind of um, life history, what sort of lives the organisms involved here possibly lead. Please email me if you have any questions. Keep on washing your hands, guys. Um, Hopefully, we'll be able to get back into the classroom, get back into the lab. We'll see what happens, but we'll find out. Again, shoot me emails if you got questions.